So, just to show you in case you forgot, once you get all these numbers in there, I can do list, math, sum. I can sum up, for example, L2, that's the probabilities. They should equal 1, and they do, thank God. I can sum up L3, so that goes right here, 45.89. And then I can sum up L4 and 2410.89. Sweet. Okay. Yes, yes, maybe? No? Yes. I like how some of you guys are looking at it like. Alright. So that's what you get when you add those bad boys up. So you've got to check this. So we just checked this. The sum of the probabilities is 1. And every probability is between 0 and 1. Check. Technically, you should say for each x, but if you don't, I know what you mean. And we all know that. Every probability anywhere has got to be between 0 and 1. You're just making sure that's true. Because, for example, real quick, do these probabilities, do those add up to be 1? Yes, they do. But is that a valid probability distribution? No, because there are probabilities that are outside of 0 to 1. So that's why you have to check both. Okay. That doesn't make sense? Just check both. At least. We have so much trouble with at least. But when you go to the, you remember when you were a really little kid and you went to Disney World or somewhere, United, whatever, and it said you had to be this tall to ride the ride, at least, and you were right here. You're like, hey, if we come back next year, you don't go back the next year, and little Jeff is like, ooh. No, sorry, remember. This is one I want to go on, and we never went back. I'm like, dude. Right, at least, which means that or freaking more, right? So what's at least 25? What age? What ages? What ages are at least 25?
Everything below 25.
Yeah, and, in the table below, but in number-wise above, right? 25, 40, all this stuff, right? So you could totally just add these up, right? What's probably, the kid thinks they'll be at least 25. It's 25 or 40, and so you add them all up. Or you could be smart and do 1 minus the only thing it leaves out. So I would do 1 minus 0.04 to 0.96. Please, dear God, if these numbers all add up to 1, Jeff, do it where your video. That's a good idea. If these numbers all add to 1, then 1 minus a piece is the other piece. That's it. That's all that's saying. So that's the idea of at least 1 generalized. The probability of something is 1 minus the probability of everything I left out. Because altogether they're supposed to make 1. Just makes sense. Okay. Now we already know this is, what's this?
45.89.
Yeah, 45.89. Another big mistake people make is this number by itself don't mean shit. It's a piece of the formula, right? Don't just square root this and be all, that's the standard. No, it isn't. So right here, this is 2410.89 minus what?
45.89 squared.
45.89 squared. And what do you guys get, sorry?
304.9.
304.9.
9.
That's it. That'd be neat. Probably more shit. Right? Woohoo! Oh yeah, definitely more shit. So if you say this, it's definitely bad. At least round it to 305, but don't even round it. And then in your calculator, be all little math people and not rounding too early, you would just hit square root of the answer. Bam! 464, I like it. All right. How are we all doing? You guys all right? Okay, I like it. Which kind of makes sense. If I had to guess, now look real quick. We know the middle is right around here, 45.89, right? How far away from that does the data get? Like 20 and 5 and 20 and 40? So I'd say an average around 20 or 30 or something. Yes?
I have a question.
Yes?
We just realized that for the 2410.89, we got 2410.94.
Neato. Double check all these. That's normally a really easy place for something to get mistyped. Double check these. If you didn't do it in the calculator, that means you might have, if you just did it one by one and rounded and then added up what you rounded, that won't come out to what I got. Does that make sense?
I didn't round. I just took the exact numbers off the calculator, and I have all of the same numbers on.
I got you. But for example, let me see, where am I at? Like this one, 60, no, actually that one's probably fine. Well, I'm not sure then what the hell you got the same numbers here?
Yeah.
Same happened to me.
No, the one.
Neato. So let's see. Stat. Yeah. Looking at it, I actually sort of agree with you. Let's see. If I do, but I just did this, didn't I? Sum up L4, and I do get 2410.89. So, guys, how much room does a calculator have to write this? It ran out of room right here. What is 65 times 18.85?
0.25.
There. Do you see that? It rounded up. How off? Do you guys see that? It's actually supposed to be 1225.25, but what does it look like on the calculator? 1225.3.
So which way would you prefer us doing? Because
I love you guys. So don't round to the very end. So if you just copy what the calculator fit into the table, it has to round if it goes further than it's got room. So if you use those numbers, you're going to be off. If you've already got it in the table in your calculator, continue using it. Do the sum of L4 and you should get exactly what I got.
Okay, so
Yeah.
sorry to go off topic for a second, but
No, this is completely on topic because I'm
on
sure
your
somebody else has got
calculator
this.
then, I know that you can do the sum of it, but how do you get there?
All right, so just remind everybody, go to second, stat, go to your list,
Okay.
go to math, and number 5 is sum. And then it can sum up L4. Sweet. Now, would I destroy you if that had happened to you? No. You'd lose a point right there, that'd be it. Right? Not a big deal. But still, you gotta be careful. Alright. Now the point I was trying to make very quickly, let me see if you guys get this. Isn't the middle right in here somewhere? Right? And how far away from the middle do the data points get? 20 away, and then another 20 and 30, 40. So on it, and then there's some that are right near it. So I'd say around 20 would be the average distance away. And we got 17. I feel pretty good. If you get 48, you should be able to tell that makes no sense. I'm not saying you have to, but you should have a way to gauge if it makes sense. Okay. Why was their standard deviation so small for the example we did? Well, they're all really close to each other. Holy shit. It should be a very small standard deviation. This one, they're much more spread out. Should be a bigger standard deviation. All right, here's that same question. I told you a while back I'd ask you the same question over and over and over again, just to really make sure you're going insane. So in the middle was the mean, of course. And just like some of the theorems we talked about, we go down and up 1 standard deviation. This goes down to 28 point something or other.
43.
And this goes up to
63.35.
63 point blah blah. Okay. So what did I catch? Which data points did I just catch?
40 and 50.
Definitely 40 and 50. So if I caught the 40s, what percentage of the data did I already catch? 23%. And I caught the 50s. So what total percentage did I catch? 41%. Done. So you know I'm going to ask you that exact question. Okay. And then finally, how many total kids did we talk to in this problem?
How did you get?
Oh, sorry.
How did you get 28?
Oh,
I'm just confused on how you got that.
Yeah.
I don't know, I just asked somebody. But if you subtract, so again, what's the idea with doing this? I go up and down 1 step. Right? I think I said 1, right?
Yeah.
Yes. I don't know why I got oh, I see, because I just realized it. So if I go down, if I subtract this from 45.99.
And then you add it?
Yep.
Okay.
Yep. We've done that before. And I told you this is going to show up over and over because there are theorems about this, and I like to make you do something concrete with it. Okay. Somebody help me out. How many total kids did we talk to? 1,200. Right? Just in case you're like, I don't know. Well, yes, you do. 1,200 kids. And I want to know how many think they'll retire before 65. So what do I have to figure out first?
Before 65.
The percentage that thought that way. So what percentage think that way? That they'll retire before age 65. So what total percentage think that way?
69.
69%. So 69% of 1,200. So what is 0.69 times 1,200? 820.
Yeah, 828.
828. So 828 kids thought that they would retire before age 65. Some of them think they're the next Zuckerberg. He's in a lot of trouble, but he still has billions of dollars, so what does he care? Plus, he's not human, so there's no emotions there. Sucker's gonna hunt me down now. Shit. Let me think. Oh, real quick, before you guys pack up, I want to show you something nifty. Always a good question is, what's this got to do with real life, Jeff? Right, you got your little stats class, and you're teaching all this bullshit, and you want to make money, so you make shit up. What do you use it for in real life? Anybody pay car insurance? Some of you guys are like, I'm supposed to. What happens? Anybody know what happens when you turn 25 with car insurance? It goes who? It goes way down. Because supposedly when you wake up on your 25th birthday, you just suddenly know how to drive right.
Yeah.
So how do they know that, of course, based on statistics. They know the probability that somebody's in an accident goes down around age 25. So they just kind of arbitrarily set it there. It could have been somewhere else. Why do they do that, though? Your rates go down, right? Why would they want the rates to be higher for the group that statistically has a higher chance of being in an accident?
So they get more money.
True, but they have to cover more accident stuff for people that will be in more accidents. So watch, real quick. If I set up a table, just like this, and I know this is how much money I've got to pay out, I don't know, as an insurance company, and I put next to it the probabilities that I've got to pay these things out, whatever these are. I'm just kind of making these up, obviously. What do I leave for this? Let's do that. I like it. Then I can figure out, if I calculate the average, that's going to be how much money I expect to pay out for each person. And there would be a different table, different probabilities for when you hit 25. The probabilities here go up and the probabilities here go down because you'll be in less accidents statistically. Are you guys kind of with me? I'm trying to show you. This is an immediate use for this XP of X stuff. Is how does an insurance company determine what its premium should be? Well, they use the probabilities that they'll have to pay out so much money for a certain group of people. So, for example, anybody get a good student discount? I don't want to send you guys on. I wish. Stop bringing it up. Why? Because statistically, better students are in less accidents. So of course they're going to give a discount there because they're not going to expect to have to pay that much out for those people. So if you're not a good student, you're less than 25 years old, you live really far away from work, you were in accidents before, your premium is going to go way up so that they still make money on their end. You guys see what I'm saying? Everything we do in this class has an immediate real-world application. That's enough. All right. So next time, oh, we're a little early. Sweet. Next time we'll do that quiz. Exciting. And then we'll keep going to chapter 4. Yeah, please don't forget your IDs.
Do you have a practice quiz? I mean, the answers to it?
Yes.
Thank you.
Oh, cool.
I have a practice. Can I just keep going